last section in this unit, 1.7. I'm hoping this is something that you're familiar with. It should look familiar. So the I can statement is I can solve absolute values. So absolute value equations and inequalities. Now, you've done equations before, but we're going to review those and then we're going to talk about how to do inequalities. So today's all going to be about equations. But as a warm-up, I want to remind everybody and make sure you remember, what does absolute value mean? A lot of people have they know how to find an answer, but they're not quite sure why that is the answer. Sometimes people think it just always turns things positive and stuff like that. We want to make sure that we understand exactly where absolute value comes from. So absolute value means distance. Absolute value means distance, and we'll talk more about that in just a second. Let's just run through and evaluate here. So this is the absolute value. Those are absolute value bars there. Absolute value of 12 is 12. Absolute value of negative 12 is also 12. Now, it doesn't just turn things positive because absolute value refers to the distance from 0. So we're going to go ahead and fill that first line in right there. So we're talking about how far is 12 from 0? Well, 12 is 12 from 0. How far is negative 12 from 0? Well, it's also 12 from 0. It's just a different direction. So if we've got the absolute value of negative 3.7, answer is 3.7. Absolute value of 0, how far is 0 from 0? 0. Okay, this one right here gets a little bit interesting. This is asking a question. How far is negative 1 from 0? Well, it's 1, and then there's a negative out in front. So the absolute value of negative 1 is 1, but that negative out front makes the answer negative. So that's kind of a unique one, and you've got to keep track of those things when they happen. And then we can also have problems inside of absolute value. You've got to figure out what the number is inside before you apply the absolute value. So you can't just go through here and say, oh, well, that just makes everything positive, and this is a 1 and a 2, and add those together. It doesn't work that way. So we've got to figure out what negative 1 plus 2 is. It's 1. Absolute value of 1 would be 1, so 1 plus 5. Answer on this one is 6. And again, this looks a little bit crazy when we have stuff like that, so I'll make those a little bit taller. That doesn't look much better, but we're going to go with it. And then on this one right here, we've got to find the absolute value of 18 minus 12, so that would be 6. So we want to find the absolute value of 6, so that would be 6. So again, absolute value refers to distance. It refers to the distance from 0. So when we're taking the absolute value of a number, the absolute value doesn't really care which direction we go. All it cares about is how far whatever is inside that absolute value, how far it is from 0. So with very few exceptions, there are always going to be 2 cases or 2 answers to absolute value problems. And the reason there are 2 cases is because there are 2 directions. And all absolute value does is it just keeps track of how far, not which direction. Again, it doesn't care which direction, it just cares how far. So again, today's just a reminder of how to solve these absolute value equations. So if we look at something like this, this is basically saying, look, when is the absolute value of 3x equal to 12? So that's like saying, when is 3x 12 units from 0? Well, there are 2 ways that you can be 12 units from 0. So let's put 0 right here. Well, the first most logical way would be for it to be over here, for it to be at 12. The other way would be you could also be 12 units away from 0 by going the other direction. So by going to the right, you get to positive 12. By going to the left, you get to negative 12. So that thing inside the absolute value either has to be right here. It's either got to be on top of 12 or it's got to be on top of negative 12. So we'd have to have 3x equal negative 12 or 3x equal positive 12. We solve each one of these, and on this one we get x equals negative 4, and on this one we get x equals positive 4. And those are the 2 solutions. Remember, we said most of the time there were going to be 2 answers. So in order to solve an absolute value equation, there are a couple things that we need to do. The first thing we need to do is we need to isolate the absolute value. If you do not isolate the absolute value first, you're going to get the wrong answer. You're going to get the wrong answer nearly every single time. So you want to make sure you're careful with that. You want to make sure that you isolate the absolute value first. Then we're going to break it into 2 cases. So here's case 1. Case 1 is we're just going to remove the absolute value as if it was never there, and we're going to solve the equation. And case number 2 is we're going to remove the absolute value, and we're going to make the number, the one on the other side, we're going to make it the opposite of what it used to be, and then we're going to solve, which is basically what we did right here. You'll notice that we no longer have absolute value on either one of these, and one of them is the 12, and the other one is just the opposite of that. It's negative 12. And this kind of relied on the fact that the absolute value of 3x was already isolated. So let me show you how this works in this problem. And I want you to make sure that you do it exactly the way I do it. There's going to be a really good reason why we do it this way. Okay, so the first thing we're going to do is we're going to isolate. So I'm going to add 1 to both sides. And again, this isn't an inequality, so we don't have to worry about anything like that. So we've isolated absolute 2x plus 3, and that equals 6. Now, one of these cases, we just remove the absolute value. So it's when it equals positive 6. I'm going to put that over here. I'm going to put 2x plus 3 equals 6. And then the other one, we remove the absolute value. So we take the absolute value off and we make the number on this opposite side, we make it the opposite of what it used to be. In other words, we turn it negative. So I'm going to put a 2x plus 3 equals negative 6. Now, what I've done sometimes is I've gotten to this point and then I kind of draw 2 arrows, one for each of these cases. This one is when we go to the right, when it equals the positive 6 or the positive 12 in that particular case. And this one is when we go to the left. So once you get that isolated, if you just think, hey, I need to break this up, I'm going to draw these 2 little lines. Do the negative one over here because negatives are always on the left. Do the positive one over here because positives are always on the right. That will also help when we do the next part of this, which will happen tomorrow. So then we just go through and we solve. I mean, you can kind of just ignore the other case and we can just go through and solve. So I'm going to subtract 3. So I get 2x equals negative 9. We're going to divide by 2. So we get x equals negative 9 halves. Okay, there's one answer. And then the other one, we're going to add 3. Sorry, subtract 3. So we end up with 2x equals 3, divide by 2, so we get x equals 3 halves. Write that so that it looks good, 3 halves. So those right there, those are the 2 answers, okay? Now, when we're doing this, I do want to point out a couple of things. So let me slide this down so we can see this, and we'll point these out. We're relying on the fact, when we have these instructions, we're relying on the fact that the absolute value is on the left side of the equal sign, like we had it on both of those. Okay, it's really important to have it on the left side. And there are a few exceptions to this technique above. There are some equations that do not have 2 answers. So there are times where you run into absolute value equations that don't have 2 answers, and we're going to take a quick look at these right now. You may remember these from last year, so let's go ahead and take a look. I'm going to isolate this one, so I'm going to subtract 4 from both sides. So that's going to give us absolute 3x equals 0. And then if we stop and think about this, this is asking when is 3x 0 units from 0? Well, that means this would have to be equal to 0. It would be kind of silly to write down 3x equals negative 0, and on this side 3x equals positive 0. We just get 3x equals 0, we solve that, and we get x equals 0. So on this particular one, we only get one solution. It happens to be 0. It doesn't always work out to be 0, and we're going to take a look at another one of those in just a second. So let's take a look at this one. Again, we need to isolate the absolute value here. So we're going to subtract 6. So we're going to end up with absolute 9x, oops, that's a minus 10. Minus 10 is equal to negative 2. Now, if you take a look at this, stop and think for just a second. This is saying that the distance this is from 0 is negative 2. Remember, distance is always positive. So what this is saying is absolute value of something is always positive, or at the very least 0. What it's saying is that this positive is equal to a negative, and that just can't happen. So what we're going to write on that is we're going to write no solution. So we'll take a look at this last one in just a second, but what I want to point out is if you ever get 0, as absolute value of a number equals 0, you will only have one solution. If you get the absolute value all isolated and it's equal to a negative, then you would have no solutions. Now let's take a look at this one right here. This one's a little bit unique. I want to make sure everybody's clear on how to do this. We cannot distribute through the absolute value like we can a set of parentheses. So these two are stuck together. It's the absolute value of that entire quantity x plus 3. So we need to get rid of the 2. So then there's usually a question, well, how do you get rid of the 2? Is that adding 2? Is it subtracting 2? What is it? Well, remember, implied multiplication, if there's nothing in between there, that's what we've got here. We've got multiplying by 2. So to isolate this, we're going to divide by 2. We end up with an absolute x plus 3 is equal to 0 on this side. So it's similar to this case over here. Remember, if you get it isolated and it's set equal to 0, we're only going to get one solution. And that solution is what you get when you take off the absolute value and set it equal to 0. This x plus 3 has to be equal to 0. So we get x equals -3. So we're going to go ahead and circle that. So remember, if you ever get absolute value isolated and it's equal to 0, you're only going to get one solution. You're going to get like a 0 or a -3 or a 15 or a 2/3 or whatever it happens to be, but you're only going to get one of them. It's not necessarily going to be 0. If you get the absolute value of something and it's equal to a negative, then you're not going to have any solutions. And those are actually kind of nice because if you think about it, you don't have to do any other work there. All we have to do is say, hey, so if you have the absolute value isolated and it's equal to a negative, you'll have no solution because there's no way that a positive is going to equal a negative. So let's go ahead and do these problems right here. Already isolated, so I'm going to break this into the two cases. Again, these little reminder lines are pretty helpful. Remove the absolute value. That's going to be the -1. Remove the absolute value. That's going to be the +1. So we're going to subtract 2. So this is going to be 5x equals -9. We're going to divide by 5, so x equals -9/5. So there's one of the answers. We're going to subtract 2. 5x equals, well, this turns out to be 5, so when we divide by 5, I end up with x equals 1. So one of the answers is a nice number, nice integer like 1. The other one is an improper fraction that happens to be negative. No big deal. We can deal with that. Okay, so on this one right here, again, we're going to go ahead and isolate. So we're going to subtract the 2. 3x minus 3 in absolute value. We get a 13 right here. Let's take a look here. We're going to break that into the two cases once it's isolated. We're going to remove the absolute value, make the number the opposite of what it was. Remove the absolute value, keep the number the same, and then just go through and solve. So the interesting thing about this is we basically do the same solving techniques. I'm going to do this one, both of these at the same time. We basically use the same solving techniques because this side is exactly the same. So this is going to be a -10. This is going to be a 3x. That's going to be a 16. We're going to divide by 3 on both sides, so we get x equals -10/3. And you can see with a little bit of practice, and I'm hoping this is coming back, these go very, very quickly, okay? Now, this one here is kind of unique. We've got this ugly expression inside, but we can deal with that. It is already isolated, so that's kind of good. So I'm going to, just for space, I'm going to draw lines like this. 3 minus 5x over 6 equals -3. And 3 minus 5x over 6 equals +3. Again, we're going to times both sides by 6, so that's going to be 3 minus 5x equals -18. 3 minus 5x, this is going to be +18, no surprise there. We are going to, let's see, we're going to subtract 3, and I'm going to focus on this one just because this one's a little harder. -21, divide by -5. X is equal to, we do want to simplify here, negative divided by negative is a positive, so we get that right there. All right, good shape. And on this one, we're going to subtract 3, -5x. Lo and behold, we get 15, so when we divide by -5, we get x equals -3. So one of them is a nice answer, the other one's kind of ugly, but that's how you do those. Oh, let me go ahead and circle these together. There we go. So those are the two solutions to that particular one right there. This should all be reviewed. You should have seen this before. That's why I went fairly quickly. If you need to go through and look at this again or need some more examples, please come get some help. Go ahead and fill out the self-assessment right here. Get working on the assignment. Get that done and then assess yourself there, and that'll give you a good sense of how well you're doing on this because you really need to know how to do this in order to be able to do the next section. Thanks.